All right. So let's continue. I hope you can hear me. Okay, so object I placed at the center of curvature. So here you are to use any of the rules. The first rule is that a ray from the object parallel to the principal axis after reflection would have to go through the focal point. So we are applying rule 1. Once the ray is parallel to the principal axis, after reflection, it has to go through, the reflected ray has to pass through the principal focus. So we have used one of the rules. Now I can also use the second rule, that a ray from the object passing through the principal focus after reflection would have to be parallel to the principal axis. Oh shit. Here, by visual judgment, you have to ensure that your ray is. You see, please, when you are doing this, you have to ensure that your line is really parallel. Because it is not so parallel, it is giving me an effect. The effect will be explained to you. But when you are doing it, you have to ensure that your line is really parallel to the principal axis. By visual judgment, you don't have to measure actually, but so I think it's parallel. So when I draw, there's the incident ray. The reflection must pass through the principal focus. And so this is the reflected ray. Let me change the marker. This is the reflected ray. Then the second one, a ray from the object through the principal focus must be parallel to the principal axis. And I have to also measure that so well. I have to ensure that, yes, I think I have that. So you join. Okay. So there's the incident, there's the reflection. Now, an image would always be formed at where at least two reflected rays converge or appear to be converging. So look at the reflection of this incident. The reflection is this. Look at the reflection of this. You see, this is where the two are converging. And that is where the image would be. That is where the image would be. The point where the rays converge will be the head. Then the tail will be on the principal axis. So this point will have the head of the image there. So the head will be here, and then the tail will be on the principal axis. So this is how the image will be formed. Now, description. Let's describe the image form. Image is formed at the center of curvature. And that's the exact position for the objects. 2, image is inverted. Look at the head is here, the foot is here, but the original image, the original object has the foot here, the head here. So here the image is inverted. Okay, now, so this is 1, 2. The third description is that image has the same height as objects. So when you look at the magnification, here it is always, magnification is always 1:1. It's always 1:1, meaning image height or size is the same as the object size. So this is the most important description or image description for the image formed when you place the object at the center of curvature. Please, any question? So, Irene. Okay, Irene, I'll take the shot and send it to the group, okay?
Yes.
Sanam. Christabel. Any question?
No, please.
Yes, go ahead, ask your question.
My image was formed at the center of curvature.
Come again.
My image wasn't formed at the center of curvature.
Because if you see, consider, did you consider this? R is equal to 2 times F. Did you do that?
Yes.
Take your measurement again. Check well. Check well. All the measurements are taken from the pole. From the pole. So if this is 5 centimeters, then from F to C must also be 5 centimeters. Or if this is 5 centimeters, then from the pole to you have to measure 10. 2 times 5, 10. So check that so well, and then use the rules. A ray parallel from the object parallel to the principal axis after reflection would have to go through the principal focus. Then if the ray from the object is true, please, we can also use the fourth rule. A ray hitting the pole reflect at the same axis, and we'll give you the same thing. So check this thing so well. I think, good. If you are not getting it, take a shot and then send it to me. I can look at it and then tell where you went wrong, okay?
Yes.
All right. Let's look at, can you try the second?
You draw the ray from the mirror.
Come again.
Please, you draw the reflected ray from the pole or from the mirror.
No, from the mirror. You see where the incident hits the mirror, you take the reflection from there. Okay.
Yes.
This is where the incident ray is hitting the mirror, and I take the reflection from the same point, but it has to go through the rules. Okay, if it's parallel to the principal axis, would have to pass through the principal focus after taking your measurement. Then if the ray is passing through the principal focus after reflection, it has to be parallel to the principal axis. And this measurement must be taken so well. All right. I want you to try the second question, that the object is between the pole and the principal focus. Use ray diagram to determine the nature of image that will be formed. Try it, okay, within about 5 minutes and get back to me. Looking at the position of the object, I cannot use the second rule, which says that a ray passing through the principal focus, because the object is in front. The object is in front of it. So I cannot use it. But I can use the third rule and the fourth rule, which says that a ray of light from the object hitting the center of curvature or hitting the mirror at 90 will reflect at the same on the same path. So I can use this and then this. And I can even use the third one, a ray hitting the pole will reflect, but it will give me the same thing. So I need only two to form an image. Now look at the reflected rays, this one and then this one. When you look at them, they will never meet in front. They will never meet in front here, because as they move or as they go, they are more diverged. Is that okay? As they move here, they get more diverged. So because of the fact that they will never meet one day in front, I have to extend their reflection backwards. So I pick on this reflection, extend it backwards. And then come and pick the other one and then extend it backward. Now, after extending the reflection, they are meeting over there. And so where the two rays appear to be meeting will be the position of the image formed. So these two rays appear to be meeting over here. This is where they appear to be meeting. And because of this, the expression of the image is that phi. Sanam, what do you think will be the nature of the image? Will it be real or virtual? Sanam?
Please, virtual.
Good. So virtual image will be formed because it is formed behind the mirror. Two, so this one, we are describing the image. Another observation, Abraham, what do you think will be a further description of the image for apart from it being virtual? Yes, let's describe the image. Come again.
Erect.
So it is erect. Yes. Image is erect. More observation. Yes. Irene, Gloria, Davina. More views. Virtual erect.
Laterally inverted.
Davina. For lateral inversion, no. That is a property of plane mirrors or characteristics of plane mirrors. Davina, come again, look at it again, and then give me an observation. Image is virtual, erect, Yeah, okay, more views to the rest of you. Sally. Gloria. Adwa. Sally talk. Kezia talk. Deborah talk.
The height of the image is greater than the height of the
Yes, yes. It's a very important observation you've made. Image is enlarged or magnified. Image is magnified. Image magnified or enlarged. Any more observation? Have you exhausted it? So it is virtual because it's behind the mirror. It is erect because head, tail. So it is erect. Then image is magnified. Yes. So here, magnification is always greater than 1. Is that okay? And then, yeah, so that's it. So these are the descriptions we can have. Please, any question?
Mr. Dear, please can you take the image formation again?
Can I?
Take the image formation again. Can you do it?
But it's 11 o'clock. You have another lesson, I guess. Okay. Do you know what? I'll fix time on Sunday. So I'll update you on the platform so that we go through it. Okay.
Okay.
Let me take a shot and then send it to the group. Meanwhile, I'll also send the YouTube link. So if you want to revisit it, you can do so. Please, at your free time, just be trying this. Place the object, okay, anywhere behind C, between C and F, and then use a ray diagram to produce an image. You can try and then WhatsApp it to me to look at it for you, okay? All right, so I've sent it into the group. So let's end the lesson here because I think you have biology today as well. Sana, am I right? All right, so as I said earlier, I'll update you so that we can go through once more. Okay, so bye-bye to all of you, okay? It's been a very turbulent session today.